What I'm about to demonstrate will change your understanding of water. These are 2 cups of purified water. What I have here is a TDS meter. It is a parts per million reader. It tells us the amount of contaminants in water. It's the tool that is used in 2012 to measure water quality. This water here is at 10 parts per million. This water here is at 4 parts per million. To give you an idea, this is tap water. And it comes in at 552 parts per million. So there's quite a difference in the purity of the water. And so this is what we're told we should drink. Let me show you why that's flawed. This is a digital pH meter. And what pH is, it's the measure of free hydrogen in a solution, such as water or any other solution. And what it determines is whether something is either on one end, battery acid, or on the other end, drain cleaner. So pH is an important science, and if you don't understand it, you probably really should look into it, because it's hard to understand what I'm talking about here without understanding that. But there's a few important qualities about pH that I'm going to touch on, and I'm going to illustrate, that show why water in its pure form is toxic for human consumption. The pH on this water is 6.8, and a fundamental principle of water is that its pH neutrality is 7, and 7 being in the middle. That means that there's equal number of plus and minus hydrogens, or males or females, however you want to look at it. It's a balance. It's neither an acid nor it's a base. It is neutral. And this water too, once again, water at room temperature should be 7.0. It should be neither acid nor base. And this is fundamental to all life on this planet. Now, let me tell you one more thing about pH. When water is purified, it loses its ability to remain pH neutral. Watch. What I have here is a pH down. It's a nitric acid. It is pH 1 or -1. It is similar to hydrochloric acid in your stomach. It's not near as toxic, but let me illustrate. We're 7.1 on this cup of water. If I add 1 drop of acid, I think I got 2, but it doesn't matter. 2 drops of acid into that little cup. Has brought that pH down to 4.5. And what that means is pH is on an exponential scale, so that means that we now have 30 times more free hydrogen atoms in there than we did before. That is 30 times more acidic than it was just a drop or 2 ago, just a bit ago. Now let's say that's in my stomach because I just drank a glass of water when I woke up. And here's another principle about pure water and pH. It mimics it and it does not dilute it. So as we add more water to our stomach, more pure water, common sense would tell us that that solution is diluted. And that actually sits at a pH of 5.0. 4, it's still dropping. It's changed like 0.2%. It's barely moved the pH. All that water did not change in pH. All that water has now become acid. And that's what happens when you drink pure water. And just to illustrate the fact, because this is kind of hard to see, is that what we can do is if we take sodium bicarbonate and we add just a pinch of it to the water, What that does is that locks the hydrogen atoms on the high side. And what that does is it guarantees that this water will pass through the human body as seawater and not as battery acid. And the importance of that is beyond any, I don't have time to speak now, but as you can see now, we've taken this water, I've added baking soda to it, it's at 8.0. It's stabilized. Here's the same nitric acid, and we can add to that. I squirted in there 50 drops dry. And still, that water now sits at 6.8. It didn't change. It's stabilized. The hydrogen's not free in the water, so it can't become an acid. And that illustrates why pure water is making everyone sick.